Hello everyone, welcome back to the course on Instrumentation and Process Control. Myself Nidhi Mehta, Assistant Professor at Chemical Engineering Department, LJIET Institute of Engineering and Technology. Today we will start with a new topic, interacting system. Interacting system is also part of a topic, response of first order system. This is one of the example of first order system, and here we will be having two different liquid level tanks, right. So let's just discuss what do we mean by interacting system. So as you can see in this particular figure that there are two liquid level tanks and those tanks are connected with each other, right. Here you can clearly see the connection, that is a direct connection with each other. So what happened, the level of fluid in both the tanks are dependent on each other. Due to the direct connection, the level of fluid or liquid inside the tanks are dependent on each other, that is it depends on both the tanks. That's why we are saying it as an interacting tank or interacting system, right. So now what we need to derive here? We need to derive a relationship between level of liquid in tank 2, that is H2, and inlet volumetric flow rate, which is Q. We are having two different tanks. First tank is having inlet volumetric flow rate of Q, outlet volumetric flow rate of Q1. Height of liquid inside this tank is H1 and cross sectional area for this particular tank is A1, right, and resistance provided to this tank is R1. Now in the second tank, Q1, which was outlet for tank number 1, serves to be input or inlet for tank number 2. As you can see here, it is serving as an inlet for tank number 2. H2 is hold up volume of liquid inside the tank 2. Q2 is volumetric flow rate coming out of the tank 2. R2 is resistance provided to tank 2 and A2 is the area, right. So this is the entire assembly of interacting system. Now what we need to do is we need to develop a relationship between H2 and this Q. So now let's just see how we can do that. So these are the steps which we need to follow to achieve our target or to achieve that term of derivation. Step number 1, we will derive a transfer function for tank 1. In that transfer function, we will develop a relationship between inlet and outlet volumetric flow rate, right. So we will develop a relationship between Q1 and Q for tank number 1. In the second step, we will derive a transfer function for tank number 2, and that transfer function will be based on the relationship between inlet volumetric flow rate, that is Q1, and height of the liquid inside the tank, which is H2. So we will develop H2 by Q1 for tank number 2. Now what we need to do is, using both the terms or using both the transfer function, we need to adopt method of elimination to reach our final term, right. Let's just see how we can do that. So here as you can see, A1 is cross sectional area of tank 1, A2 is cross sectional area of tank 2. Coming to assumptions, we are again having those three same assumptions which we have done in liquid level system derivation, right. That is, cross sectional area of tanks are considered to be uniform throughout the cross section. Liquid is assumed to have constant density. Flow resistance is assumed to be constant. So these are the three basic assumptions which we need to follow. Now let us just start our derivation. So when we are doing derivation for the first tank, what we need to do is mass balance, right, or volumetric balance. So it will be Q minus Q1, inlet which is Q minus outlet which is Q1 equals to, this is volume, so we need to do the volume balance, right. So area into height will give us the volume, so it is A1 dH1 by dt. This is accumulation term. In simple, the equation which we have used in our liquid level system, the same equation will be used in this interacting system. So it will be inlet minus outlet equals to accumulation. Same way for tank number 2, inlet is Q1, so it will be Q1 minus outlet is Q2, so it will be Q2 equals to A2 dH2 by dt. Now, the important thing or the thing which is slightly changed in this derivation is the flow head relationship for tank number 1. For tank 2, it is the same as we have done in liquid level system, but for tank number 1, it will be changed. So, flow head relationship can be written as Q1, that is outlet coming from the tank 1 or volumetric flow rate coming from the tank 1 is equals to difference in height. Which height difference? Difference in height of liquid of both the tanks, tank 1 and tank 2. So, hold up volume or hold up liquid of tank 1, that is H1, minus hold up liquid of tank 2, that is H2, right. So, H1 minus H2 will be the driving force here for flow rate. So, Q1 equals to H1 minus H2 upon R1, which is the resistance provided. Now, for tank number 2, flow head relationship is as simple as it was in liquid level system. So, it will be Q2 equals to H2 by R2, it is in the simplest form. Now, what we will be doing here is, we will take steady state condition for those flow rates. So, it will be Qs minus Q1 of S equals to 0 for step number 1. Step number 2 can be written as Q1S minus Q2S equals to 0, right. So, once we subtract equation 5, as you can see from equation number 1 and equation 6 from equation number 2, you will get this equation when you subtract it and introduce deviation variable. So, small q minus qs can be written as capital Q, Q1s minus Q1 minus Q1s can be written as capital Q1 and so on, right. So, once we subtract that equations and introducing deviation variable, we will get this equation. Now, same thing for equation number 3 and 4, we are just introducing the deviation variable. It will be in the form of Q1 equals to capital H1 minus H2 and the same way here. Now, taking the equation number 8, 7, 8, 9 and 10, all 4 equation we have taken here, just shifting these terms here. As you can see, we have just shifted the terms here, right. So, now what we need to do is, we need to use this equation. In this equation, we need Q and we need H2, right. So, we will take first equation, we will try to substitute the value of Q1 and H1. Just substitute the value of Q1 from equation number 12, that is tank 2 equation, this one. Q1 equals to Q2S plus A2S H of S. Substitute it here. In the same way, substitute value of H2S from this equation, right. So, substituting the values of equation 12, 13 and 14 in equation number 11, we can get our desired term, which will be in the form of H2S by Q of S equals to R2 upon tau 1 tau 2 S square plus tau 1 plus tau 2 plus A1 R2 S plus 1. Right. So, this is the final equation for interacting system. So, this is all about interacting system. So, let us just again do a quick recap of what we have covered in interacting system. Right, so doing a quick recap of this session is, now let's just do a quick recap of what we have covered in this particular session. So we have talked about interacting system, in which the level of liquid or the flow rate which is coming out of the system depends on the height of liquid in both the tanks, and due to this phenomena only the system is termed as interacting system. So we have started with the 3 major steps. In the first step we are doing or deriving transfer function for tank number 1, and that transfer function is based on the ratio of Q1 by Q. In the second step we will derive a transfer function which is based on tank number 2, and it will be in the form of H2 by Q1. In step number 3 we will utilize both the equations and will try to substitute the values and get our desired result by elimination method. Right. So these are the assumptions which we have done, and this is how we have proceeded. Right. So for tank number 1 we have written an balance equation, for tank number 2 we have written mass balance equation, then simply the flow head relationship we have written for both the tanks, as in case of first tank it depends on both of them. So it will be Q1 equals to 1 by R1 H1 minus H2. In case of tank number 2 it depends on Q2 equals to H2 by R2. Right. After doing that we have transformed the terms, taken derivative of it, right, or deviation variable of it. We have taken the deviation variables and then we have taken the Laplace of all the 4 equations. Once we have taken the Laplace, we will be using these 4 equations to get our desired results. So for that we are taking the transfer function equation of tank number 1. We will use elimination method and substitute the values of unwanted terms from rest 3 equations. For an example, this is our equation, right? So we don't need Q1 in our final term. So we will substitute the value of Q1 from equation number 2 or from transfer function of tank number 2, making Q1 as subject. Again, we don't want Q2 term in our final results, so we will substitute its value from this equation, Q2 equals to H2 by R2. In this way, we are just going to use elimination method so that all the terms except capital Q of S and H2 of S are replaced, right, and we will be then taking the terms common and take the ratios to get the desired results of interacting tanks. So this is the transfer function for interacting tank. Hope whatever we have covered today is quite clear. Thank you.